Oh, welcome back to the channel. This video, I'm going to focus on Cambridge IGCSE Physics Paper 2, May June 2024, Paper 22. Are you ready? Let us get started. Now, question number 1. A student wishes to measure accurately the volume of approximately 40 cm cube of water. She has two measuring cylinders. One large one which can hold 100 cm cube and the smaller one which can hold 50 cm cube. The water forms a meniscus where it touches the glass. Which cylinder and which water level does the student use to ensure an accurate result? Now, since the student wishes to measure the volume, which is only about 40 cm cube, of course, we would never advise the student to choose the larger measuring cylinder because due to the gap between the scale of the reading of the measuring cylinder might be too large and 40 cm cube might be in between the scale and which makes the reading to be taken inaccurately. So since the volume is lesser than 50 cm cube, right? This student can choose a smaller measuring cylinder and the water level. If you remember your paper 6, one experiment is about measuring the volume, how to measure the volume accurately from the measuring cylinder. You have to place your eye level. Your eye level must be perpendicular to the scale on the measuring cylinder, and it has to be below the meniscus, right? Meniscus is like a curve form between on the water surface on the measuring cylinder. So you have to place your eye level here below the meniscus or bottom of meniscus. Therefore, C is the answer for the first one. Now, the second question, motion of an object is represented by the speed-time graph as shown. Which quantity is equal to the area under the graph? Now, let us do a bit of refreshing a bit. When a speed-time graph is being given or any graphs is being given, bear in mind, there are two information that you could obtain from the graph. One is called the gradient of the graph. The other one is called the area under the graph. So these are the two information that you could obtain from a graph. Now, since this is a speed-time graph, the gradient of the graph represents acceleration, whereas the area under the graph represents the total distance traveled. Total distance traveled by the object. Isn't the answer is very obvious? Which quantity is equal to the area under the graph? This is the distance traveled. Question number 3, an astronaut of mass 80 kilogram is standing on a planet with gravitational field strength. G is equal to 3.8 Newton per kilogram. It's definitely not on Earth. Don't you think so? Because the gravitational field strength on the Earth is 9.8 Newton per kilogram. Right? So this is way smaller. So you can float. What is the weight of the astronaut on this planet? Weight, if you recall the equation of weight, W is equal to mg, where W represents weight, M represents the mass, G represents the gravitational field strength. Now, every information is given. Mass is 80 and G is 3.8. So you just multiply both, you get 304 Newton. Round it off to 300 Newton. B is the answer. Question number 4, a sealed container of volume 2000 cm cube contains air at high pressure. So the container is placed on the top pen balance and the balance reads 200 gram. This 200 gram is the mass of the air plus the mass of the container. Now, all the air is being removed, pumped out, and the balance reading changes to 196 gram. 196 gram is the mass of the container, because all the air is being pumped out, remember? So what is the density of the pressurized air? So density of the air must be equal to the mass of the air over the volume of the air. Remember that. Mass of the air is equal to the mass of the air plus container, which is 200 gram, minus the mass of the container only, which is 196 gram, which gives you 4 gram. Now, 4 gram, and the volume of the air is given, which is 2000 cm cube, 2000 cm cube. The reason why I did not convert my gram and cm cube to kilogram per meter cube is Due to all the choices, I can see that the unit of A, B, C, D are all in gram per cm cube. So I don't want to waste the time to convert to kilogram per meter cube. So when you do it, you should get 0.00200 gram per cm cube. Three significant figures. A is the answer. Now, question number 5. Each diagram shows three forces on a beam. In which situation is it possible for three forces to be in equilibrium? Now, before I give you the answer, let us talk about the conditions for a system or an object to be in equilibrium. Now, there are two conditions to be fulfilled. The first one, resultant force acting on the system must be equal to 0. That also means that the outward force must be balanced by the downward force, forward force must be balanced by the backward force, right? That is about resultant force. Second condition is that the resultant moment at a point in a system must be equal to 0. That also means that the total clockwise moment must be equal to the total anti-clockwise moment. So we are going to look into that one by one. Now, first, I want to determine the resultant force first because that's the easiest one. Outward force, the balance by the downward force, right? Look at A, look at A. It seems like when I base on the height of the arrows, it seems like two down arrows balances the upwards arrows. So I say resultant force is equal to 0 for A. Resultant FR represents resultant force, right? For B, okay, if I say that these two slanting forces are balanced, right? But there is no downward force to balance this upward force. Therefore, B resultant force is not equal to 0. B is definitely not in equilibrium. What about C? Maybe I could say that these two forces, even though the angle seems to be a little bit different, if I say that these two arrows, right, slanting arrows balance each other, but there is no downward force to balance this upward force. Therefore, the resultant force is also not equal to 0 for C. So C cannot be your answer. What about D? Oh, the two outward force seems to add up to become the balance to the downward force. So I can say that D might be the answer as well. You see, I want you to see this word, possible, right? So we have to make some guessing here. Now, the other situation is that the total moment must be equal to 0. In order for you to find a moment, you have to set a pivot first. Now, let me set my pivot here for two cases here, A and D, because I know that B and C cannot be the answer, right? So for A, I know that there are only two forces that are acting. One is upwards, the other one is downwards. For B, there are also two forces. One is downwards, the other one is upwards, right? So how to do our guessing? Let me write down the equation of moment first. Moment is equal to the force times perpendicular distance from pivot. So if you want a moment to be larger, the force must be larger. The perpendicular distance from the pivot must be longer as well. Look at A. A, the force is definitely, upward force is definitely larger than the downward force because it is longer. And the perpendicular distance from the pivot is also longer as compared to the downward force here. The perpendicular distance seems to be smaller, and the magnitude of the force seems to be smaller as well. Therefore, the moment produced by the downward force is smaller as compared to the moment produced by the upward force. A cannot be equilibrium because it seems like the moments, right? The outward force produces, this is clockwise moment. Downward force produces anti-clockwise moment. It seems like the clockwise moment for A is larger than the anti-clockwise moment. So no, it is not possible to be in equilibrium because for a system or an object to be in equilibrium, these two conditions must be fulfilled. What about D? Okay, the smaller force is acting outwards. The distance is longer as compared to a larger force, which is acting downwards. The distance is shorter, I would say. Right? So the outward force produces clockwise moment, whereas the downward force produces anti-clockwise moment. It seems like smaller force with a larger perpendicular distance can balance a larger force with a smaller perpendicular distance? What do you think? So I would say that possible, right? For D, clockwise moment, it is possible for the clockwise moment to be equal to anti-clockwise moment. Therefore, the most possible answer is D. Question number 6. A gymnast jumps from a high piece of apparatus. She gradually bends her knees as she lands. Which effect does this have? You could see that even long jump as well, they would actually like high jump or jump from a tall place like that before landing. So they will bend their knee first before they stand up, right? So why? Reason is because it is due to this. Force is equal to the rate of change of momentum divided by time taken. Bending of knees could actually increase the time of impact because when the knee is bent, right, this gymnast would take a longer time before her feet touches the ground. So when it takes longer time to touch the ground, the impulsive force or the impact force acting on the gymnast, the impact force acting on the gymnast could be decreased because the change in momentum is the same. The speed of the gymnast, the mass of the gymnast is constant, right? So the force is inversely proportional to time taken. Longer time, smaller impulsive force. Let us look at A. She will have smaller change of momentum as she lands because momentum depends on her initial speed, her final speed. Her final speed must be equal to 0. Depends on her initial speed, right? So momentum is the same. The change in the momentum of her is the same, right? Now, B, she loses less kinetic energy as she lands. Kinetic energy depends on her speed. So in this case, her speed is the same. So that is why this is not possible. C, she will exert a smaller impulse on the ground. Impulse is the change in momentum. Since the mass and the speed are constant, the change in momentum will be constant as well. So this is not possible. She will experience a smaller force from the ground as she lands, which is true, to decrease the injuries on her. So that is why smaller impact force, smaller injury. D is the answer. Number 7, the table gives 4 energy resources and states whether the main source of energy for the resource is the sun. Which row is correct? So let us look at A. A is geothermal. The main source of energy is definitely not the sun. This is a no here. Why? Because geothermal is the energy from the inner core of the earth. It does not depend on the sun. A cannot be your answer. B, oil. The main source of energy? Yes, it is the sun because you need the sun to decompose the dead animals, the dead plants, yeah, to be able to form the oil. C, water held behind a dam, right? The main source of energy is the sun. Yes, through the rain, evaporation caused by the sun, and then they gathered from the cloud, and then eventually there goes the rain and filling the water behind the dam. This is true. C is the answer, but I will prove D is not the answer. Energy resource is a wind. Main source of energy is not the sun. This is wrong. Main source of energy of the wind is actually the sun. You know why? Because sun gives out energy, gives out heat in all direction. So some of the region, they get hotter as compared to the other region. So based on the concept of heat, heat would transfer from the hotter region to the colder region. Due to the transfer of heat, from the hotter region to the colder region, the air particles will move from the hotter region to the colder region. The movement of the air particles give you wind, right? So C is the answer. Question number 8, the equation delta P is equal to rho G delta H can be used for a liquid. What is the meaning of the term rho? Rho is not the pressure due to the liquid. In fact, P is the pressure due to the liquid. Rho is the density of the liquid. Yes, B is the answer. C, the total pressure due to the liquid and the air above the liquid, you have to add atmospheric pressure. So it is not represented by the symbol rho. Density of the object placed in the liquid, that is also not true. Rho GH, the rho represents the density of the liquid. Now, question number 9, what are the correct terms for each change of state? Liquid to solid, solidification becomes solid, okay. liquid to gas. Condensation is not true because condensation is from gas to liquid. Gas to liquid. So this is wrong. Condensation is wrong. And melting liquid to solid is not called melting, but it is called freezing. I will write down the correct words here. See, liquid to solid, yes, solidification. And liquid to gas, evaporation, sounds correct. Liquid to solid, it is called not melting, but it is called freezing. Yeah, so therefore the answer is C. Question number 10. Extremely small pollen grains in water are viewed through a microscope. The grains are seen to move continually and randomly. What is the reason for this random movement? Now, you have to recall, right? Brownian motion. Do you still recall? Brownian motion, right? The small pollen grains are moved in zigzag motion, random motion is due to the collision between the small pollen grains and the even smaller water molecules. Let us look at A. The grains are moved by randomly moving water molecules. Sounds correct. But I'll look at B, C, and D first. B, the grains are moved by random convection currents in the water. No. C, the grains are moved by random rays. Nothing to do with the ray of light. This is water. D, the grains are moved by random motion of their own atoms. No, that is not true. They are being bombarded by invisible, even smaller water molecules in all directions. That is why they seem to move in all random zigzag motion. A is the answer. Question number 11, which graph shows how the volume of a fixed mass of gas at constant temperature varies with its pressure? Now, this type of question is super duper important. Don't you think so? Right, when the temperature is constant, okay, fine. We put it as room temperature. How about that? I want to link to the real life situation. Now, I have a space which is, I feel so comfortable, right? To do my studies, to do my work, etc. So when you put more people that close to me, so there are tables that maybe you put some tables beside me and put more people beside me, I feel not so comfortable because I don't have a bigger space, my own space, right? So you will feel pressure when your own space is limited. Do you get me? So when the volume increases, the pressure, okay, or the volume decreases because your free space decrease, right? We link to volume. Free space is my volume. When my volume is decreasing, the pressure in me will keep on increasing. I don't like people to come close to me, right? I feel pressurized. Can you see that? When you give me more and more and more space, you remove people, right? So I feel more comfortable, less pressure. So you could see that when the volume is decreasing, the pressure will have to increase. The D is the answer. Now, question number 12, which effect is caused by thermal expansion? Right, let's look at 1A first. A metal surface heating up in direct sunlight. Metal surface heating up in direct sunlight. Is it called metal surface heating up in the direct sunlight? Thermal expansion? Right, B, ice cream melting on a hot day, it would not caused by thermal expansion because this is just a melting process, a mere melting process. C, a railway track buckling on a hot day, which is true because the railway is made of a metal. They will have a little bit of space there in order for that metal to expand. Right, C is the correct answer, but I'll look at D first. Ice forming on a pond on a cold day, nothing to do with thermal expansion. Right, so when the metal surface is being heated out at the direct sunlight, right, it is only at the top surface of the metal, right, that causes the particle or the atoms in the metal to receive thermal energy, which they could vibrate more. So that is not called thermal expansion, right? So they will vibrate more. on the atoms on the surface of the metal would just vibrate more. So C is the correct answer. That is the effect. That is why our railway track is built with some gaps between them in order for the material to expand during the hot day. Now, question number 13. The temperature of the water at the bottom of the waterfall is greater than the temperature of the water at the top. Energy in the gravitational potential store of the water at the top is transferred to the thermal store at the bottom. Specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. What is the temperature difference for a waterfall of height 21 meter? Now, for this type of question, I have to use principle of conservation of energy. So the initial energy is being converted to final energy. Initial energy has to be gravitational potential energy because this is the energy, I will highlight this, the energy in the gravitational potential store of the water at the top transferred to thermal. They have already given you the clue. So the gravitational potential energy is being transferred to the thermal energy, right? So I will say heat or thermal energy. Gravitational energy, potential energy is mgh. Heat or thermal energy is mc delta T. Remember that? Now, I will have to cancel m and m. Just ignore that because I don't use it. G is 9.8. H is 21 because it is given. This is a height. C is the specific heat capacity of the water, which is 4,200. Temperature difference is delta T. So I make delta T as a subject. Delta T is equal to 9.8 times 21 divided by 4,200. So it is 0.049 degrees Celsius. B is the answer. Now, question number 14. An ice cube is placed in a beaker and it is heated. The ice melts to form water, which evaporates at first and then boils. The steam condenses on a cool window in the room. There are so many processes now. Which process involves transfer of energy from the ice, water, or the steam to the surrounding? When the ice, the water, or the steam transfer the energy to the surrounding, that means they have to lose the energy. They have to give out the energy, right? Melting process. For melting, energy need to be absorbed first in order for the melting process to occur. So A, for melting, energy must be absorbed, not being transferred out. B, evaporating. Evaporating, energy need to be absorbed instead of transfer out. Boiling, of course, you need to supply the heat. That is why energy is being absorbed. Condensing. What about condensing? Gas particle change to liquid, right? Gas particle wants to change to liquid. Distance between the gas particle has higher kinetic energy, so it has to give out energy in order for the particles to come closer and turn into liquid state. So this D is the answer. Transfer of energy to the surrounding. Yeah, it is losing energy. Now, question number 17. A teacher shows his class a polystyrene cup. The polystyrene is a thick plastic with lots of tiny air bubbles in it. He asked the class why the cup is so good at keeping a hot drink warm. 3 suggestions are made. Which suggestions are correct? Now, let us look at the first one. It contains air, which is a poor thermal conductor. This is definitely true. Second, the air is trapped in tiny bubbles, so very little convection is possible, which is true. Third, plastic is a poor thermal conductor, which is true because plastic is an insulator. So the 3 suggestions are all correct. A is the answer. Question number 16. 2 samples of the same material have the same mass but different surface area. Everything else same, it's just that surface areas are different. Each sample is heated to the same temperature and then left to cool to room temperature. Each sample is allowed to cool to the same final temperature as well. Which row correctly compares the decrease in the internal energy and the initial rate of cooling for each sample? Now, I would have to agree with the decrease in the internal energy. Internal energy depends on potential energy and the kinetic energy. So since they are the same materials, definitely they have the same potential energy because they have the same mass, they are made of the same material, right? And each sample is being heated to the same temperature. See, cool down to the same temperature, same room temperature, right? And their final temperature is also the same. So kinetic energy depends on the temperature. Since both X and Y are of the same temperature, therefore the kinetic energy must be the same, right? So the change, the change in kinetic energy must be the same. So since the potential energy and the kinetic energy of these two materials, X and Y, are the same, so they will lose the same amount of internal energy. What about the rate of cooling or the rate of evaporation, right? Since Y has a larger surface area, most of the heat could evaporate very quickly from Y to the surrounding. That is why the Y will cool down faster as compared to X. D is the answer. Question 17. In which type of wave is the direction of vibration parallel to the direction of travel? Right? Direction of the wave, which is parallel, this is called longitudinal wave. Longitudinal wave. You could see that electromagnetic waves are transverse waves, so this is not the answer. Transverse wave. This is not the answer. Seismic P waves are longitudinal wave. B is the answer. Seismic S wave is a transverse wave. Transverse wave. And water wave is definitely a transverse wave. Therefore, the answer is B. Question number 18. Waves in a ripple tank are diffracted as they pass through a narrow gap. What can be done to make the spreading due to diffraction greater? So in order for the wave to diffract or spread out even greater, you have to increase the wavelength. Wavelength, two conditions. Wavelength increases, I put arrow out, mean increases, and the gap needs to be decreased, smaller gap. Right. Oh, they didn't talk about the wavelength. They talk about the frequency. Now I have to use V equals to F lambda. If I assume, oh, in this case, A, decrease the frequency and the speed is constant. Let us see. Speed is constant. Frequency is inversely proportional to wavelength. So when the frequency is decreased, automatically the wavelength is increasing. Decrease the frequency, wavelength is increasing, and keep the wave speed constant. Seems like A is correct, but I will check on B, C, and D. Decrease the speed of the wave and keep the frequency constant. No, you won't not increase the spreading, right? So this is no. C, increase the frequency. When you increase the frequency, wavelength is decreasing. So that is also not true because I want the wavelength to increase in order for more diffraction to occur. D, increase the frequency, wavelength will have to decrease. So this is also not true. Therefore, the answer is A. Question number 19, diagram 1 shows the page of a book in front of a plane mirror. An eye is looking at the image of the page. Diagram 2 shows a large letter G on the page facing the mirror. What is the appearance of the image of G seen by the eye? Do you remember one of the characteristics of the image formed by the plane mirror is laterally inverted? Raise out your, if the object, raise out me as the object, raising out my left hand, laterally inverted, my image will raise out the right hand, right? So if you see this G, right, the G, that seen image of the G is actually inverted, laterally inverted. Now, question number 20, the diagram shows a ray of light passing from air into diamond. What is the refractive index of the diamond? I'm so interested, right? Right, so first of all, write down the equation of the refractive index. N is equal to, since the ray coming from less dense, which is air, to denser, which is diamond, so we use psi I over psi R. I is the incident angle. R is a refracted angle. Now I want you to see this. Incident angle is not given. This is a tricky question over here. So how do we find incident angle? Incident angle is the angle between the incident ray and normal. The normal is not being drawn. So you have to draw your own normal line here. What is normal? Normal is an imaginary line which is perpendicular to the two surfaces, to the diamond surface, right? So incident angle is this one. Refracted angle is this one. How do I find incident angle? It's a little bit of math here. I take 90 minus 60 to get my incident angle, which is sine 30. And 90 minus 78, I get 12, so sine 12. N is equal to sine 30 divided by sine 12, I get 2.4. There's no unit for refractive index, so C is the answer. Question number 21. The ray diagrams show the formation of an image by two different converging lenses. Which row describes the image produced? These are the image formed by the converging lens, right? The image produced for diagram 1, in diagram 1 is here. This is the image. When the image is formed in front of the lens, which is on the same side as the object, image is called virtual image. This is where the image is being formed for diagram 2. When the image is formed at the back of the converging lens, the image is called a real image. Therefore, C is the answer. Question number 22. White light enters a glass prism. The light leaving the other side of the prism is separated into colors. This is called dispersion of light. Which row correctly describe what happened? Right, so the path taken cannot be diagram 1 because in diagram 1, it seems like this part of the light is not being dispersed, right? Whereas it has already passed through the glass prism, right? Diagram 1 cannot be the answer. Path taken by the light cannot be diagram 1. It has to be diagram 2. It has to be refracted already, right? Refraction by the glass prism is called dispersion. So diagram 2 is the correct path. And color number 1. Remember color number 1, it has to be red color, right? Why red color? Because red color has the longest wavelength. So it will travel more before being refracted. And color number 2 is called violet. C is the answer. Now, question number 23, thermal radiation is part of the electromagnetic spectrum. What is the name of this region of the spectrum, right? The thermal radiation is called infrared. 24, a remote control vehicle is traveling on the surface of the planet. The vehicle senses an obstacle ahead. It sends a radio message to the control room from where it is being controlled. The control room is 2.4 times 10 to the power 6 kilometers away from the vehicle. Control room sends a message back to the vehicle telling it to stop moving. What is the minimum time that elapses between the vehicle sensing the obstacle and receiving the message back from the control room? So I would say that maybe different planet, maybe this is a planet where the control room, and this is where, okay, this is the vehicle. Okay, there's an obstacle in front, right? So this is another planet. So this vehicle will send, okay, to the control room, which is 2.4 times 10 to the power 6 kilometers away. And this control room will send back the signal. Can you see? To and fro, the same distance, back to the vehicle. Right, telling it to stop. What is the minimum time? Right, the vehicle sensing the obstacle and receiving the message back. I am going to use a simple equation, which is V is equal to 2 times the distance divided by time, because distance traveled by the signal must be to and fro, right? So it sends, okay, maybe it seems like we have lack of information, but this is a clue here, a hint. Send a radio message. Send a radio message using a radio wave. A radio wave is one of the electromagnetic waves which travel with the speed of light, which is 3 times 10 to the power 8. 2 times the distance, that means 2 times 2.4 times 10 to the power of 6, and kilometer, you have to change to meter because speed of light is meter per second. Change to meter, you have to times 1000 divided by time. Time taken would be equal to 2 times 2.4 times 10 to the power 6 times 1000 divided by 3 times 10 to the power of 8. So the time is 16 seconds. D is the answer. Number 25, which statement about the direction of the magnetic field at a point is correct? It is actually the direction of force. Field represents the direction of the force on a north pole placed at that point. A is the answer. Question number 26, a student draws graphs of an AC supply and a DC supply. Which row shows the correct labels for W, X, and Y? Okay, now let me see. Label of W, oh, the y-axis, and the y-axis. Okay, this is the y-axis. So the label of W must be a voltage because y-axis, right? So it is actually the voltage. AC supply is the one that is moving, right, like a wave direction, because AC supply is a supply that changes its direction every half a cycle. Therefore, AC supply is Y. DC supply, DC, that means the voltage is always constant. D is the answer. DC supply is X. Number 27, a resistor transfers 100 joules of energy when a charge of 10 coulomb flows through it. What is the potential difference across the resistor? They give us the energy, they give us a charge. I remember E is equal to VIT. And I times T, Q equal to IT. Q it! So this is a charge, right? Energy is 100 joules. I need to find the potential difference, which is a V. Q is 10. V is 100 divided by 10. V is equal to 10 volt. B is the answer. Question number 28, wire X and wire Y are made from the same metal. The table gives information about the two wires. What is the resistance of wire Y? Okay, now I have to do it. I said that, I write down the equation for the resistance first. We know that resistance increases as the length of the wire increases. And the resistance will decrease as the surface area of the wire increases. Larger surface area, more charges can flow, more current will flow through. That is why the resistance decreases. So I combine these two, I get resistance is directly proportional to L, but inversely proportional to surface area. I want to get rid of this proportionality symbol. I put a constant, K, just put K times L over A. Now, I just sub in my value of K. How about that? So the resistance for wire X, I put X here first. Yeah, this is wire X. Question number 28. Resistance of wire X is 2. And then K, the length of wire X, length and cross-sectional area, I'm not going to change the cross-sectional area to meter square because for Y, it is also in millimeter square. So I'm just going to put it, just the number will do, 1 over 0.4. And I put K as the subject. So K is equal to 0.4 times 2, which is equal to 0.8. For paper 2, that's the advantage. You don't have to bother about the unit because the K that we are going to use for wire Y also use the same units. So we can cancel off. So for wire Y, I don't know the resistance of wire Y, so I would just put RY, resistance of wire Y, but it is still KL over A. So resistance of wire Y is equal to 0.8 times the length of wire Y, which is 1.3, cross-sectional area is 0.3. So when I work it out, I get 3.467 ohm, which I round it off to 3.5 ohm. D is the answer. I use simultaneous equation actually. Right, question number 29. The diagram shows two resistors used as potential divider. The reading on the voltmeter is 1.8. So I better write it down. This is 1.8 volt. What is the resistance of resistor R? So for potential divider, I'm just going to put this V output over V input is equal to resistance that is connected to voltmeter, which I call it as R output over R input. R input, that means the total resistance of the whole circuit. V input is the total potential difference or the total voltage supplied to the whole circuit. V output is given as 1.8. V input is equal to 3 volt. And then R output is the one that connected to voltmeter, which is R. R input, the total resistance. This is R plus 5 kilo ohm. I don't have to change the kilo ohm to ohm because all the choices A, B, C, D are all in kilo ohm. Now cross multiply, I have 1.8 R plus 5 is equal to 3R. Work it out. Okay, so this is 1.8 R plus 1.8 times 5, which is equal to 9 is equal to 3R. Now I continue here. So 3R minus 1.8 R is equal to 9. 3 minus 1.8, which is equal to 1.2 R, is equal to 9. R is equal to 9 divided by 1.2, which is 7.5 kilo ohm. Therefore, C is the answer. Now, 30, two electrical appliances are connected to the mains supply. The cable connected to one appliance includes an earth wire. The cable connected to the second appliance does not need an earth wire. What is the reason for this difference? The reason is because why we need an earth wire? Because one appliance has a metal casing. What if the wire inside the metal casing is loose and touches the metal case and you so happen to touch the metal case, you will get electric shock. That is why we need an earth wire, right? So that is the function of the earth wire. So A is the answer. Number 31, the diagram shows a simple AC generator. The magnet rotates around a fixed coil wound around a fixed iron core. The electromotive force, EMF output is a sine wave, a series of crests, zeros, and troughs. The magnet is shown in 3 positions, P, Q, and R during its rotation. Magnetic field in coil is 0 at Q, but changing most rapidly at Q. Could you see that? So which statement about the induced EMF of the coil is correct? Could you see that for position P and position R, there is no cutting of magnetic field occur because the wire is here and the magnet is just outside of the wire when it rotates. So I would say the EMF induces in position P and position R would be equal to 0. And the position Q, so because this is the wire between the magnetic field of the magnet. So when the magnet rotates, right, it will give maximum cutting of magnetic field occur, which induces the most EMF. Maximum EMF will be induced at position Q. So that is why the magnitude of the EMF at position Q is definitely, because it is maximum, it is larger than position P and position R. A is the answer. Magnitude of the EMF at position P and R are 0. Number 32. A 24-volt power supply has a 100% efficient transformer used to light a 6-volt 12-watt lamp. What is the current in the power supply? Now, when you see that the question I have already mentioned that this is 100% efficient transformer, that also means that the total input power is equal to the output power. Input power, I will put I input, V input. Output, I will put I out, V out. Input power is already, the input voltage is given. So I have to find the input current. Input voltage is 24 volt. Output current, output voltage, this is output power. So I'll just put it 12 here. This is 12 watt. I input is equal to 12 divided by 24, which is equal to 0.50 ampere. A is the answer. Question number 33, the scattering of particles by a thin gold foil provided scientists with evidence for the nuclear atom. Which particles were scattered by the gold nuclei in the thin foil? It is actually alpha particles. Question number 34, a nucleus X has 17 protons and 18 neutrons. Which notation is correct for this nucleus? For a nucleus, you have to put X first. Nucleic notation, you have to start with nucleon number. Nucleon number is the sum of proton numbers plus number of neutrons, which gives you 35. So A is 35 and Z here represents a proton number. So it has to be 35, proton number is 17 and X. D is the answer. Number 35, the dashed line on the graph shows the decay curve recorded from a sample of a particular radioactive isotope. The count rate includes background radiation. What is background radiation actually? The background radiation is unwanted stray radiation detected by detectors somehow. Because our detector is not the picky one, so it will detect any radiation, right? That is a bad thing. So which curve show the corrected count rate for the decay? So the corrected count rate must be lower because the background radiation, because they add the stray radiation, that is why the reading would be higher. So therefore, B is the answer. So it has to be corrected, must be lower at any point. That is why the answer is B. Question number 36, which type of radioactive source is suitable for use in measuring and controlling the thickness of paper in paper manufacturing factory? The answer is actually beta. Beta particle must have a long half-life in order for you to use a longer period of time. Question number 37, a medical tracer is used to investigate a tumor in a patient. The graph shows the corrected count rate from the tracer against time. What is the half-life of the source? When a graph is being given and there's no mention of background radiation, you are safe not to include the background radiation. You look at the time. When the time is equal to 0, what is the initial count rate? It is 10,000. This is what we call initial count rate. Initial count rate, which is equal to 10,000 counts per second. So at half-life, remember what is half-life? The definition of half-life is the time taken for a radioactive nuclide to decay to half of its count rate. So this count rate must decay to half of its initial value. So you take 10,000 divided by 2. So you get 5,000 counts per second. So where is the 5,000? Oh, the 5,000 is here. Look at the 5,000 and look at the time taken to decrease to 5,000. That would be your half-life. 2 minutes is the answer. Question number 38. The Earth orbits the Sun once in approximately 365 days. The average radius of the orbit is 1.5 times 10 to the power 11 meter. What is the average orbital speed of the Earth? Average orbital speed of the Earth is 2 pi r over t, because one complete cycle is actually the circumference of a circle, which is 2 pi r. And one time taken for one complete circle is period. Right, so now what's the average orbital speed? 2 pi r is the average radius orbit, which is 1.5 times 10 to the power 11 t. Look at the orbital speed, must be in second. This is 365 days. 1 days you have 24 hours, 1 hour 60 minutes, 1 minute 60 seconds. Right, so you have 2.999 times 10 to the power of 4 meter per second. So I round it off to 3 times 10 to the power of 4 meter per second. A is the answer. Question number 39. Which statement about the life cycle of a star is correct? A, all stars eventually run out of hydrogen as fuel because the process of fusion keeps on occurring. Yeah, so eventually they will run out of hydrogen. This is true. Now, B, a red giant forms a planetary nebula with a supernova at its center. No, not for red giant. Red giant is like the medium-sized star, like our sun, right? Supernova must be formed from a very, very big star, super red giant. So this is wrong. C, a white dwarf star eventually forms a black hole. No, never ever forms a black hole, right? So this is wrong. And D, most stars expand and forms protostar. Not possible as well, not most stars, right? So A is the answer. Question number 40, which is our last question here. A galaxy at a distance of 3.1 times 10 to the power 21 kilometer is moving away from the Earth with a speed of 7,000 kilometers per second. What is the Hubble constant, H naught, calculated using this data? And what is the speed of galaxy at a distance of 6.2 times 10 to the power 21 kilometer from the Earth? So now we calculate the Hubble constant first. It is equal to the speed of the galaxy that is moving away from the Earth divided by the distance between the galaxy and the Earth. So the speed of the galaxy, which is 7,000 kilometer 7,000 kilometer per second, divided by the distance, which is 3.1 times 10 to the power 21 kilometer. I don't convert my kilometer to meter because kilometer and kilometer can be cancelled off. Therefore, I get 2.258 times 10 to the power of negative 18 per second. So I round it off to 2.3 times 10 to the power negative 18 per second. For the first one, Hubble constant, so it's either A or B as your answer. So the speed of the galaxy, so I use speed of the galaxy, V is equal to Hubble constant times the distance. Hubble constant is 2.3 times 10 to the power negative 18 and times with the distance, which is 6.2 times 10 to the power of 21 kilometer. Not going to change that kilometer to meter because the speed of the galaxy must be in kilometer per second. So I got for this one, I think I got 14,000 kilometer per second. B is the answer. So that's the end of our discussion for May-June 2024, paper 22. I hope you gain benefits from that. If you have any doubts, please do comment below. See you in my next video. Bye.